And good day to all the grade 10s. Welcome to the STEM Lockdown Digital School. Welcome back to those who joined us yesterday. And once again, let's welcome our new members who are only joining us for the first time today on this platform. My name is Katleho Matibe, and I will be presenting this grade 10 life sciences lesson to you guys. Now, guys, please remember to use the chat tab if you have any questions that you'd like me to answer. And if I am moving too fast, please do tell me, or if you cannot hear me, do tell me, then I'll restart the section that I was currently at, and then, yeah, we're moving forward. Let's enjoy the rest of the lesson. And please, guys, cooperate and respect other participants. Let's respect one another. My email address, whereby you can send me any questions that you have regarding life sciences, is ls.wisnet@gmail.com, or you can use my Twitter handle @cat_lake for anything related to life sciences. Now, as you know that we had started off on the history of life that falls under the strand diversity, change, and continuity. Yesterday, we were focusing on fossil formation and methods of dating. Now, today we'll be continuing with this topic, and hopefully we get to finish because it is our last topic that we'll be dealing with under the history of life on Earth. So today we'll be talking about the key events in Southern Africa and fossil tourism. Now, at the end of this lesson, I want you guys to be able to define concepts that are highlighted in bold black, to explain what is meant by the term living fossils, to provide possible reasons why these fossils have survived. I want you guys to provide evidence found in South Africa relating to the history of life, to explain the impact humans have on biodiversity and the environment, and lastly, to explain what fossil tourism is and how it impacts the economy. Now, just to quickly recap on yesterday's lesson, we touched base on fossil formation. We said fossil formation takes places in a step-by-step process. So fossils are formed in a step-by-step process as time lapses by. We said organisms that live by the sea or by the river, they die there, and then they sink to the bottom of the sea. As they sink there, they decay, the soft material of the organism decays, and the mineral salts then filters through the body of that organism. Later on, the organism becomes petrified, meaning it is turned into a stone. And as soil erosion occurs, it washes over all the soil, and then the fossil is exposed into our eyes. Then we get to see scientists saying they have found a certain fossil at a certain area. Now, methods used to date these fossils, we mentioned two. These are the relative and the radiometric dating methods. So under relative, we know that relative does not give the exact age of the fossil, but an estimate of the year or era it existed in. And under radiometric dating, we said that it can sometimes be called absolute dating because it can give you the exact age of the fossil. It uses radioactive substances to date fossils, and we gave an example of the isotope carbon-14 as the radioactive element that is used to date such fossils. And these fossils, we name them as index fossils. Now, I gave you a homework. I hope you guys did that homework and will give me answers quickly. If one can give me the answer for number one and the other one can just give me the value for number 2A, which is X. If another participant can give me the value or answer for number 2B, which is Z, number 3, and number 4. So quickly, guys, I'm giving you like 2 minutes to answer, to give me the answers, to give me the answers to these questions, and then I'll also provide you guys with the answers. You know, you can take a screenshot or later on download this video on YouTube to see the answers if you're not sure. So guys, I'm waiting for your answers. Quickly give me your answers, guys. So I see we have a new member by the name of D Low. Welcome to our digital school, and please go through our YouTube channels to see other videos of where we started off. Okay, so you can read up on this topic, the history of life on Earth, on your own. Go to the videos for clarification. Use the email if you are unsure. Number one, guys, I need answers for these questions. Sorry. I do not have a Google Drive where you guys can find these documents. I said if you need any help, use my email address and then I can send you guys these, but they will be on YouTube. So number one, Nelly says it's radiometric dating and relative dating. Thank you, Nelly. Thank you, Miss P, for the answers. For number two, what is the value for X and what is the value for Z? X is 28,650 years. You have to have units, guys. You know you have to have units. But thank you, Pia. And then for number B, for number Z, for the value of Z, number 2B, what is the percentage? The percentage is 3.125%. Thank you, Jenna. Thank you, Nelly, for the answers. Good. And then for number 3, I see people are getting the same answers. Explain why it would be not possible to date the fossil of an organism that existed 80 million years ago using the decay of carbon-14. Remember, carbon-14 is not the only radioactive element that we use to date fossils, simply because it has relatively a short half-life. So Ponzo Maila is asking for my email address. My email address is ls.wiznerds@gmail.com. Jenna says you would have to use uranium. I will type it out for you guys. You would have to use uranium, but why? It says explain. So in a test or an exam, you guys have to explain such. It is simply because uranium has a larger half-life as composed to carbon-14, meaning that it can date older fossils. Now give 2 reasons why there are gaps in the fossil record. Yes, thank you, Gina, for the answer. She says uranium has a greater half-life. Correct. So Nelly says it also only dates samples more than 40,000 years old. That's correct, guys. Thank you. Now give 2 reasons why there are gaps in the fossil record. Okay, so because time is not on our side, I'm quickly gonna go to your answers and then you mark yourself if you are correct. So your answers are, for number 1, it's any of the 2 of the following: radiometric dating, which uses minerals and volcanic rock; radiocarbon dating, which uses organic fossils like bones; relative dating, where one fossil is dated as being younger or older than another without giving a specific date or age. Remember, it just gives us an estimate. So for number 2, you simply multiply 5,730 years times 5 because it's on the 5th row, which gives you 28,650 years. And then for number B, you divide 6.25% by 2 because we want the half-life, or simply multiplied by 0.5, which equals to 3.125%. You guys got all of these right. Number 3, a fossil that is 80 million years old has almost no carbon-14 left in it. Therefore, the amount will be too small to be detected. Now, carbon-14 would not give a reliable date or age. That is the explanation why we cannot use carbon-14. And then you can add on your uranium, but this is the reason why. So number 4, it's any of the 2 of the following. Why there are gaps? So there are gaps because not all fossils have been found yet. Fossilization is rare, so not all dead organisms fossilize. Many fossils have been destroyed by movements of the Earth's plates, and we call that, or we explain that under plate tectonics, the theory of plate tectonics, or by human activities like digging and dam building, where we cut down trees, deforestation, and other man-made activities that we are doing that are harming our environment. The other reason can be soft-bodied organisms do not usually fossilize, so very few of them are present in the fossil record. And any other relevant fact may be accepted. For example, people may not recognize an item as a fossil, so it goes unnoticed. Okay, guys. Now moving on to today's topic. So key events in Southern Africa. Remember, Southern Africa, we're not talking about our country, but the southern part of Africa. I hope we're on the same page. So what happened millions of years ago until now in the southern part of Africa? One of the oldest evidence of life on Earth is found in Barberton in Mpumalanga, that is in South Africa. These are fossilized photosynthetic bacteria cells. Fossilized photosynthetic bacteria cells. So these fossils are about 3,400 million years old. And the bacteria had jelly-like substances around it. Now, fine rock particles became attached to this jelly-like substance, forcing the bacteria to grow upward to search for light. Remember, we said that they are fossilized photosynthetic bacteria cells. So it means that they use up light. When you photosynthesize, you need the source of energy, which is your light. And you use up carbon dioxide to produce water and oxygen, something like that. You guys know it. Let me not say something like that. Excuse me for saying that. Now, this results in the formation of a structure called stromatolite. So as these fine rock particles become attached to this jelly-like substance, it forces the bacteria to grow upward to search for light, which result in the formation of a structure called stromatolites. Now, these are examples of stromatolites, and stromatolites are dome-shaped mat-like layers of rock. You usually see this when you are by the ocean. You probably didn't know what these rocks were called. So these are stromatolites. So as you can see on the second picture, yeah, it's like a dome. It's shaped like a dome. So these are dome shaped mat-like. It's like a mat. So when you are far away, you can see that it's like they are so joined. They look like a mat-like layers of rocks. So the oldest fossil of multicellular organisms that we know is found in Namibia. So the oldest known multicellular organism is found in Namibia, and those are the sponges called Otavia. So as you can see, Otavia is in italics, so it means this is the scientific name of this sponge, this multicellular sponge. Remember I said scientific names are written in italics? Or in a test or an exam, you guys should write first the genus name, which should be capitalized, followed by the species name, and then you underline it. So we don't want to see you guys writing in italics. So you write the genus and the species name, underline it. Now they are found in limestone rocks found in northern Namibia. In limestone rocks. So yesterday we looked at sedimentary rocks and we said limestone is an example of a sedimentary rock because limestone has layers. Those layers, they show us that as years went by, sand and silt was washed into the sea and then it formed this rock, the oldest layer at the bottom followed by the younger layers on top, forming this limestone rock. So these fossilized sponges are thought to be 650 million years old. And a similar type of fossil and fossils of other soft body invertebrates have been found in the Northern Cape. So as you can see, if you look at our map, if you look at Africa, basically in the southern side, you can see that Namibia and South Africa are closely, no, I meant to say Northern Cape is closer to Namibia, just that there's a border dividing it. Okay, so Northern Cape is in the Karoo. So fossils of algae and early land plants have been found in the Eastern Cape near Grahamstown. These fossils are about 350 million years old, and nearly 280 million year old fossil of cone bearing plants have been found near the Moy River and Escott in KwaZulu-Natal. So a picture of an example of this cone bearing plant is here below. This is a picture of a Glossopteris fossil. So a Glossopteris fossil is a cone bearing plant, a fossil of a cone bearing plant that was found right here in South Africa in KwaZulu-Natal. So as you can see, Glossopteris, it's written in italics. It means that it is the scientific name of that particular fossil of a cone-bearing plant or tree. Now looking at Glossopteris. Glossopteris, these fossils occupy the Gondwana land for almost 60 million years ago, and were responsible for the coal deposits found in the southern Africa, in the southern side of Africa. So these fossils, they were responsible, this tree, cone-bearing plant, was responsible for the coal deposits found in the southern part of Africa. So the picture is just a reconstruction of what the Glossopteris may have looked like. Okay. You know that we are producing coal in South Africa, and we are using that coal for electricity and other stuff. So this is the fossil that was responsible for the coal deposits that we are finding right now in our country. So this is the species that was responsible for that. Now looking at this map, it shows the coal deposits in South Africa. If you can look at it, your Western Cape area, a bit of Northern Cape, Free State, Eastern Cape, a bit of KwaZulu-Natal, Gauteng a bit. That's where you find your coal deposits in South Africa. Hence, we have our coal mines, even in Mpumalanga. So maybe there's the blue line coming up from, I do not have a pointer, forgive me for that. So there's blue line here. It passes through, right here is Limpopo, Mpumalanga. So that's also the reason why we find the coal mines in those provinces. Now, as we look at animals that we think might have existed in Africa, in the southern part of Africa, we're focusing first on reptiles. So fossils of reptiles such as the Lystrosaurus and the Thrinoxodon have been found in the Karoo. So these reptiles, pardon me for that, were believed to give rise to mammals. Now quickly tell me what mammals are. What are mammals? And they lived between 280 and 100 million years ago. Now this picture below here is a picture of a Lystrosaurus, and this is a picture of a Thrinoxodon. Now these reptiles were believed to give rise to mammals. What are mammals? So Ms. P is asking if you should know all of this for your exam. Yes, you should. Because you might get a question saying, write an essay on the key events of fossils that were found in the southern part of Africa, or if they ask you of a fossil, as you know, in a test or exam, they just take a certain part of a theme and they test you on it. So now, all of this you should know. But at the end of my slides or the presentation, I have a worksheet that you guys can use. There's a link there. You go there, you see that worksheet just to get an idea of type of questions that might be asked. So you should know this. And Ms. P says, mammals are animals that walk on 4 legs. What about humans? What about humans? Are we mammals? Do we fall under mammals? Yes, we do, but we do not walk on 4 legs. Now, Letavo Shadun says mammals are warm-blooded creatures. Yes, mammals are warm-blooded. They have fur or hair, and the females produce milk for the nourishment of the young, meaning that they give birth to live offsprings. Thank you, Litawa. They can give live birth. Talita says animals that give birth like humans. Yes. So humans are mammals. Now we're looking at dinosaurs. So last week I asked you guys if dinosaurs were herbivores, carnivores, or omnivores. I didn't get an answer or a response on that. I would like you guys to tell me if dinosaurs are or were herbivores, carnivores, or omnivores. So dinosaurs lived 210 million years ago in Lesotho, the northeastern of Free State, KwaZulu-Natal, and the northeastern part of Eastern Cape. So dinosaurs did live in South Africa. So this was supported by findings of fossilized footprints of dinosaurs in the areas. And fossilized dinosaur bones have been found in Maluti and Drakensberg mountain ranges. Hence, you see that at the museums. If you've been to a museum, if there are some of you who are in Pretoria, you know our museum, the museum that we have, Dijong Museum, there's a dinosaur bone structure outside. So it shows that these were found right here in South Africa. So are dinosaurs herbivores, carnivores, or omnivores? Let me go back before you see that. They differ to the type of dinosaur. Thank you, Talita. So they differ to the type of dinosaur. Not all are herbivores or carnivores or omnivores. So they differ to the type of dinosaurs. So right here we have the Euskalosaurus. Wow, did I just make a mistake like that? Forgive me for saying that. It's the Euskalos. This is so funny. Forgive me for saying that. It is the Euskalosaurus, and it was a very early dinosaur. It was a herbivore. It means that it fed only on plants. And the first fossils of skull and skeleton were found near Ladybrand in the Eastern Free State. So this Euskalosaurus was a very early dinosaur, and it was a herbivore. So this is a type of a dinosaur that was a herbivore. As you can see on this picture here, it is feeding on a tree to simply tell us that it was a herbivore. So it did not eat meat or any animals. So it wasn't a carnivore. Now there is evidence of early mammals in Southern Africa. And this is a shoe-sized mammal found in the Eastern Cape province and Lesotho. The caves of the cradle of humankind contain most of the fossil evidence of early humans. And the evidence of human existence can also be found in the Free State, KwaZulu-Natal, and Eastern Cape. This evidence is in the form of fossils and artifacts. The evidence is in the form of fossils and artifacts. So we have the coelacanths. The coelacanths are fish-like organisms that are also found in South Africa. So the diagram here shows an example of a coelacanth. So some of their fins are lobe-like. This and many other features have led scientists to believe that they are more closely related to amphibians than fish. It looks like a fish, hence I said it's a fish-like. But they are closely related to amphibians. Oh, I'm sorry, Jenna. I'll go a bit slower. And Miss P is asking why they are called early humans. Are they not apes? Letavi Shadung is answering her. She says, not exactly. Yes, they are not apes. But remember that we fall under the same genus. So we have similar features. So looking at that family tree that I once mentioned, that Homo sapiens are similar to the Homo erectus, which were your apes and the family of monkeys. So those were the early humans, because we don't know that humans were they able to speak back then or whatever. It goes with evolution. That's why there's the theory of evolution. Okay, Miss P. What are amphibians? Just give me an example of amphibians so that we can help others. Because it says here that scientists believe that they are more closely related to amphibians than fish. So Talita is raising her hand. You may type in your question because all of you guys are muted. So coelacanths were thought to have become extinct about 70 million years ago. However, see that they say they were thought to have become extinct. Now, however, in 1938, a living coelacanth was caught off the coast of East London, and a population of about 15 coelacanths have been found near the Sodwana Bay. Now, we call these fossils the living fossils because scientists thought that they were extinct. But then later on, they found some that are living, so they thought wrong. So these are living fossils. People had forgotten about them, but then they saw them again. Now I might be asked to explain what a living fossil is. So an example of a living fossil is a coelacanth. A coelacanth. I have a few multiple choice questions for you guys. Please just quickly answer these for me. Number one, the group name given to the first life forms which developed on Earth about 3.8 billion years ago is A, Otavia, B, Glossopteris, C, photosynthetic bacteria, and D, dinosaurs. Just choose the correct answer. Give me the alphabet for that. Number two, the strange looking fish once thought to be extinct over 70 million years ago is called A, Coelacanth, B, coelacanth, C, coelacanth, and D, coelacanth. Just choose the correct one. Remember spelling. We do give marks for spelling errors, but as I told you, terminology is important for you guys. I want to see if you will get this right. Number three, cone-bearing plants that are responsible for the formation of the coal deposits in Southern Africa. So A, coelacanth, B, Glossopteris, C, conifers, or D, Euscalosaurus. So number one is C, photosynthetic bacteria. That's correct. Number two is C, is the coelacanth. Thank you, guys. And what is number three? Number three is B, the Glossopteris. That is correct. Now, these are the correct answers. Moving on to human impact on biodiversity and the natural environment. So threats to biodiversity and the natural environment, some of those are habitat destruction, natural disasters, overexploitation, pollution, pesticides and fertilizers, climate change, alien invasive species, and diseases. Now we can relate to the last point of diseases. Currently, we have a pandemic that is affecting the whole world right now. So these are threats to biodiversity and the natural environment, both man-made and natural. So they are both man-made and natural threats. Now, starting off on fossil tourism. Fossil tourism is a type of ecotourism, but in fossil tourism, the main attraction is its fossils. One of the most famous fossil sites is the Cradle of Humankind. Most of you have been there, and most of you have heard of it, even read about it. So the Cradle of Humankind is found in Gauteng and Northwest Province. There's a picture of the Cradle of Humankind. Now, focusing on the Cradle of Humankind, it is found in Sterkfontein, Swartkrans, and the Kromdraai regions. It is a World Heritage Site. A World Heritage Site since 1999. So it is one of the richest source of fossils of early humans. Ms. P, I hope you are paying attention to that. Early humans. So nearly half of all human ancestor fossils have been found here. Remember, our ancestors are those apes that we said apes, but we are sharing the same genus and class. We fall under the same class. So it has yielded so many significant fossils such as Mrs. Plas, the little foot, and the recently discovered Karabo child, which was discovered in 2008. The scientific name for Karabo child is the Australopithecus sediba. Australopithecus sediba. So here we have a picture of Mrs. Plas. So this is how Mrs. Plas was or is. And on this side, we have an image of Karabo child, the Australopithecus sediba Karabo child that was discovered in 2008. The other type of fossil tourist attraction site in South Africa is the West Coast Fossil Park, which is found in the Western Cape Province. It is found along the west coast, a few kilometers inland of the Langebaan Lagoon. So Ms. P is asking, how is Corona a threat to our biodiversity? Remember that Corona is killing most of our people. It decreases population size, but then there is a disadvantage. But then an advantage is that the environment, our environment is taking a break now because we are now indoors. So we have reduced movement and we are no longer going to work, meaning factories have now taken a break from producing all these gases that are harmful to the atmosphere. So it is a blessing in disguise, as I mentioned last week during our lesson when we were talking about climate change and geological events. So the West Coast Fossil Park, it was once a phosphate mine, and it had the greatest diversity of 5 million old fossils. So it contained the fossils of the first bear ever found south of the Sahara, And some of the fossils that were found there are the extinct true seal and the 4 extinct species of penguins. Okay, so these fossils were found there. The extinct true seal and the 4 extinct species of penguins. The West Coast Fossil Park is found in the Western Cape. Remember that. So there are many hands-on activities at the park that makes it very exciting for the tourists. So one of the hands-on activities that takes place there is that tourists can sift in the sand looking for fossils with the promise that if you find something new that no one has found, then it will be named after you. So plans have been put into place to start a national fossil and rock art route that joins the fossil park to the cradle. Now this here is an image of what you will find when you get to the West Coast Fossil Park. You will definitely find these structures. This was taken there. There was a picture taken at the West Coast Fossil Park. Pardon me for that. Another tourist attraction site is our museums. So important fossils have been moved to museums once they have been discovered. Guys, we have 5 minutes left for our lesson. So important fossils have been moved to museums once they have been discovered. And the dinosaur fossil found in the Karoo, it has been moved to the museum in Graaff-Reinet. The museums become important fossil tourist attractions. So there's a picture of the Ditong Museum that I told you guys about that is in Pretoria, Gauteng. So what are the advantages of fossil tourism? So fossil tourism creates jobs, it generates income for people living in those areas. It creates business opportunities for travel agents and tour operators, and simply just strengthens the economy of our country. So these are just the advantages of fossil tourism. Now homework for you guys. Give me a few disadvantages accompanied with fossil tourism in South Africa. Number 2, name 2 fossil sites in South Africa. And number 3, name 1 fossil that was found at each of these 2 sites that you would have named above on number 2. Now that is all that I have for you today. And the takeaway message is that in the last 4 million years, significant changes have occurred in species acquiring in Africa. These include the evolution of humans, and South Africa is rich in many fossils from diverse time periods. And lastly, that fossil tourism is a source of income and employment in fossil localities. This is your takeaway message. Now, these are the helpful links that I used. You guys can use these links to read up more on that or your textbooks. And I mentioned the worksheet link that you guys can go through and try to answer questions on that. Use that worksheet link to see the type of questions that are asked in tests and exams. Now, from tomorrow, we'll be starting on our term 2 content, which is on the chemistry of life. So guys, if you have time, just read up on inorganic compounds. That is what we'll be dealing with tomorrow. And thank you for tuning in and being part of our lesson. Don't forget to follow us on social media at Africa Teen Geeks on all social media platforms or on our website. My email address is ls.wisnes@gmail.com. Guys, have a lovely afternoon and thank you very much for tuning in.